I'm working for Kersia. And if I may, just one quick slide to start off with. Kersia may not be a name that you're familiar with. It started as a process with Pred, which was a private French chemical company, which had some backing, venture capitalist backing by RDN, and set off down a series of purchases, including purchasing Holchem in May last year, and then just very recently Sapura. So we are all now part of the Kersia group, and there's some statistics there at the top to say that essentially Holchem has now gone from UK, primarily UK and Ireland company, to now part of this global business. So what are we talking about in terms of removing bacteria from surfaces and some of the problems that we have through CIP? Just to stress that microbial elimination is a process including cleaning, and any remaining bacteria are then subject to a disinfection procedure. So we have to start off with soil removal. The images are simply different product soils, maybe some scales, maybe some microorganisms. Those may all develop on the inside of pipes and vessels that require cleaning at the end of the process. The cleaning part is relatively simple and hasn't changed for many years. We still rely on the Sinner cycle. We rely on chemistries to select for the particular soil type. What has changed substantially is our concept of microorganisms, where they might be hiding, the principles of hygienic design, and the targeting of those organisms through disinfection or thermal processes. So just going back very briefly to the concept of cleaning, Sinner's cycle is something that was developed by a German scientist probably in the 1950s, I think, but had the concept that you needed physical energy, thermal energy, chemical energy through detergents, and a fourth factor, time, and you could manipulate those energies to give you a clean surface. Similarly, the concepts of the different food types, fats, carbohydrates, proteins, an appropriate detergent type to break those fats, carbohydrates down, and the action of that breaking down have been well established for many years. So that puts us into a position really of default. So if we were to approach a brewery or beverage CIP situation or a dairy situation, there is a fairly established default practice that you would put in place to assess whether the soil was removed, and you might manipulate that a little bit until you got to the situation of visual cleanliness, or perhaps a little further if you were measuring by ATP or some other measure. So that's your starting point. That is hopefully giving you a clean surface, at least a visual cleanliness, and removing the food soil. But then it comes down to a consideration of what you're actually cleaning yourself. And many people switch off at this point. They see this complex system of pipes and vessels and valves, etc. And how can you break that down into simple assessments of whether the system is cleanable? And in all my life, I would say 99% of the problems that I've been associated with to try and investigate microbial spoilage have come down to the simplistics of hygienic design and the inability of the plant to clean itself. So we need to think about surface finish, we need to think about crevices in the surfaces, dead areas where we don't have the penetration of the cleaning fluid, drainability, we don't want fluids left in the system, and the importance of the flow rates through the vessels and through the pipes to give us that cleanability. So starting with surfaces, there is a relationship between the surface area of a microorganism and the surface area of the surface that we're trying to clean. And the relationship is that the greater the surface area of contact between the bacteria and the surface, the more strongly the bugs are adhered, the more difficult they are to remove. And in some cases, the more difficult it is for disinfectants to come close to the cell to give that disinfection action. Routinely, we measure that surface roughness in terms of roughness average, and it is an imaginary straight line through a surface, and the roughness average relates to the peaks and the troughs of the valleys and the mountains, etc., and expresses that as a figure in microns. We can measure it relatively simply, and you get cheap surface profilometers, or more expensive ones if you're a manufacturer, and you can specify your surface finish. You can measure it at the point of manufacture, you can measure it at the point of purchase. Most guidance documents suggest a surface finish of less than 1 micron. And we can then start playing games with, well, does a crevice need to be where it's retaining microorganisms to where it's large enough for cleaning fluids to get in and remove them. And we also, it's not always the concept of a straight line, and we see a picture at the top of a polished type 4 surface, but it also relates to surface features and how they trap microorganisms. The second one is the concept of crevices, and we started in the dairy industry many years ago with couplings that were metal to metal. They didn't have a gasket, and when you tightened up a piece of metal, then it was leak proof. However, the best engineers in those days would work to 1/1000th of an inch, and if you thought you could machine something to 1/1000th of an inch, that was fantastic tolerances. But in reality, a bacteria is 1 to 2 microns. 1/1000th of an inch is 25 microns. So if you see a metal to metal surface, in reality, what you're seeing is a 10-lane motorway for bacteria to move in and out between those two metal to metal surfaces. So we fill those metal to metal joints with a gasket. The gasket is designed to be compressible into the features of the surface, so that the gasket takes up those imperfections and makes it such that a microorganism cannot hide there. You have to have the right pressure of the seal, and also you have to have the right gasket hardness to make that operate. We have different types of couplings. The one on the left is the basic German DIN coupling, and you can see inside it there is an annular crevice all the way round. The gasket does not sit flush with the inside of the pipe. So we have a crevice all the way around here where microorganisms and food soils can gather. This is the American style clamp arrangement, and the diagram below shows that depending on how tight you turn that, you can either extrude the gasket into the pipeline, which then causes problems of cleanability, or you might not extract it enough, compress it enough, which has the reverse of the problem, but still difficulties. The ultimate goal at the moment is this German DIN coupling, which replaced the original one, which compresses the gasket nicely into its crevice. Dead legs and upstands. We're in a scenario here where the flow of the cleaning fluid in a particular direction may have problems in cleaning if an upstand or a T-piece is too long. And the diagrams below suggest the flow rates and shear wall shear stress, which is much less in these upstands or T-pieces. And there's diagrams of upstands and T-pieces on the right hand side. And there is a relationship between the length of the upstand and the diameter pipe, such that the upstand should be no more than the diameter of the pipe. And if you get to that situation, you will have a cleanable system. In terms of drainability, what we don't want is fluids left in the system. Fluids allow microbial growth, but if they're chemicals, they also allow corrosions of gaskets. On the left-hand side, the tanks are obviously undrainable. On the right-hand side, they are drainable. That's relatively straightforward. Similarly with the pipes on the bottom, the pipes, because of sag or bend or expansion from one to another, create undrainable zones. Slightly more difficult on the right-hand side, these are perfectly acceptable hygienically designed centrifugal pumps or rotary pumps, but if they're installed in the wrong direction, they have undrainable sections. So in this case, on this rotary pump, the bottom rotor is completely full of fluid, water, product, chemicals at all time. It accelerates the deterioration of the gasket in that particular point, and then the gasket and behind it starts harboring microorganisms, and I've often seen problems with particularly E. coli related to this sort of arrangement of installation of what was a hygienic component. Flow rate, we're trying to achieve about 1.5 meters per second. There is a relationship between speed of flow of the fluid and also removal of bacteria from the surface. In this top diagram, we have laminar flow. There's little exchange between the flow and the chemicals in the flow with the surface. In the bottom, we have a more turbulent flow. There is interchange that gives us cleanability. So we're trying to maintain 1.5 meters per second as a flow rate. This diagram at the bottom right here is a butterfly valve showing the valve and some of the speed or velocity profiles through it. And you can see that generically it's very cleanable, but at its trailing edges, then flow is, and there might be problems. So anything in the flow that, anything physically in the flow may then reduce its cleanability. In terms of vessels, we have two types of approaches. We have a falling film from a spray ball, sprays the vessel, the film falls down and cleans, or we have impact sprays. The problems related to those are in terms of just the normal falling film. If we have pooling of water in the vessels or cleaning fluids, we don't get that falling film. So in this case, a scavenge pump at the bottom is not working as fast as the supply pump, and it gives us problems. With the other types of impact systems, shadowing is the greatest problem. So we have a spray ball and we have a shaft there, and there's a shadow through which you can't clean on the other side, and you might have to put more spray balls in. So disinfection, ultimately, you can use chemical disinfection. You can't use some chemicals because of foaming problems such as QAs and amphoterics. Historically, we've used sodium hypochlorite, but now it's much more common to find peracetic acid as the disinfectant. And as long as you're aware of the classic disinfection issues of concentration and contact time, which are more important really than temperature, then chemical disinfection is perfectly acceptable. On the thermal side, it gives us a little more ability to select perhaps the target microorganism, and as long as we know what its D value is and the appropriate times and temperatures, we can heat the plant to that time and temperature to control that microorganism. And simplistically, you run the thermal cycle until you have the right temperature on the CIP return, then you start a contact time. There can be problems around the plant because not all of the plant will get to the temperature that you need it to get, particularly some of those decks where there's no flows. So you can use the concept of thermal imaging to try and tell you what the external temperature of the plant is. And the last one for me, just the concept of the European Hygienic Engineering Design Group. And if you are not familiar with that, I would point you in that direction. They have some excellent documents on hygienic design of most components of a CIP set. but they've also published relatively recently this hygienic design of CIP set document, which goes through the principle, and it really is a fantastic document. So that's me. Thank you very much.
Has anybody got any questions for John? I can't see any questions in the Q&A, John.
Okay.
If anybody would like to unmute themselves and ask a question, please do.
I can see there's a comment here in the chat box from a Richard Scott. It says, if you have a mixed system such as a vessels and pipeline, is there a preference which one is cleaned first, or should they be separated?
They're normally cleaned together as part of the same system. Is the question is it more difficult to clean vessels or pipelines, or are you more likely to have microbiological problems in either? And if that was the question, then the pipework tends to be the more likely source of microbiological problems, because there's more hygienic design features within a pipeline that make it sometimes a little more difficult. Complex pieces of equipment may also create difficulties, such as heat exchangers, etc. But vessels themselves tend to be relatively simple structures.
Thank you. Thanks. Is there any more questions? Feel free to type it in the chat box as well if you are unable to type it in the Q&A.
Great, then Dee, I think we should hand over to the next speaker, and thank you, John.
Pleasure, thank you.
Fantastic, thanks Daniel. So if I do that.
Yeah, we can see that, Peter.
Fantastic. Good morning, ladies and gentlemen. Thank you to the BFBi and SDT for asking me to come and talk to you this morning about cleaning and allergens. My name is Peter Littleton. I'm Technical Director for Christeyns Food Hygiene, and it's absolutely great to be sharing the stage with John again. And I'm also looking forward to the time we can both get back to actually walking about during our presentations rather than just sitting in a chair talking into a headset. So if I start moving things along, quite a tall ask, similar to John. Probably when he heard that we'd got sort of 15 minutes to cover the subject, it was a bit of a, okay, what do we put in? What do we leave out? So this is quite a surface skim of allergens and cleaning, and we've supplied a white paper on allergens and cleaning and the interaction and management thereof, which will be circulated to participants later, which gives a heck of a lot more detail. So in these 15 minutes or so, hoping to cover a little bit on the background of allergens, talk about the cleaning, common problems, a little bit on testing, and something on disinfection. First of all, for those of you who don't know, I'll take the opportunity to also introduce my company, Christeyns Food Hygiene. We are an international group active in applied chemistry. We are privately owned, which gives us great advantages in terms of being a family operation operating internationally. Our HQ is in Ghent, and there are some great advantages to working for a private organisation, in that you know, we can get answers really quickly. There are some slight downsides in that questions can also be asked very quickly. So there's fors and against, but we operate in over 30 countries with customers on 5 continents and in over 50 countries of the world. And we are the second largest supplier in the world of peracetic acid, as John has mentioned, a widely used disinfectant, particularly in the CIP sector. But we are a family. We are a family of experts, and we put safety first. with our expertise and our passion to develop continuous improvement, and some customers there that you may recognize across the food, dairy and beverage sector. Because when I refer to food in any of this presentation, that's food in its widest terms and its legal definition of anything basically that we consume. So that includes food, drink and beverages. Right, on to the main thing, allergen control and cleaning. First of all, just to make sure we've all got the same baseline, what are allergens? Well, an allergenic reaction is the body's response to a protein that, quite simply, it's the immune system reacting to a protein that it doesn't recognize and doesn't like. Not limited to food. Obviously, we're talking about food sources here, but other allergies do exist. So you've probably heard the two that I mentioned on screen there in terms of familiarity. So latex allergy and bee stings. So it's any reaction to a protein which is not recognized by the immune system. So roughly, and it varies a little from country to country, but in general terms, it's about 2 to 3% of adults and about 5 to 8% of children are known to actually suffer from true allergic reactions. So this is where the immune system overreacts. But a further 35 to 40% of the population, and that figure is growing, perceive themselves as suffering from an adverse reaction to food, and that can either be an intolerance, and we'll come to that in a moment, or it can be psychosomatic. You know, they kind of been poorly after eating something once, and that means that they then feel that they have a reaction to that product. Across the UK and in the EU, we still have the EU list. We list 14 common food components that must be considered as allergens and declared on the label of prepacked foods. More are actually being considered. There's a lot of talk at the moment of adding kiwi to the list of the allergens, which includes things like gluten, shellfish, milk, etc. And there is new legislation coming into force in October this year that requiring food that is sold loose to also have its allergenic components declared or labelled. And that's because these reactions can vary from mild irritation to full anaphylaxis. And probably the most well-known case certainly in the last couple of years was Natasha. Natasha who unfortunately was lost her life through a reaction to sesame after eating a sub roll on a BA flight, and her parents have been campaigning extensively since with the support of the Anaphylaxis Campaign, which is an organisation I'll mention shortly, who are to get the food sold loose, the non-prepacked food, also suitably labelled so that sufferers know what's there. There's also a lot of research going on into treatment of sufferers, and there's been some press coverage in the last couple of weeks of some immunotherapy treatments to look at being able to reduce particularly peanut sufferers. Some time ago, if we talked about allergens, people probably thought of nuts and peanuts. Now it's as you saw from the figures there, a lot more common. Now, food intolerance is different to food allergy, but it still can be triggered by the same food ingredients and food components, but that's a digestive abnormality. So a good example there is lactose intolerance, so the inability to digest the sugar that's common in milk. And if you recall the figures a few moments ago, a large proportion of the population, anywhere up to 35 to 40% of the population, suffer from some form of food intolerance. And this may sometimes be lumped in with things like IBS, irritable bowel syndrome, as a blanket umbrella covering statement. So that's the problem. We are dealing with a component in food, and in a component that can be in lots of foods, that is really there as an ingredient and can cause consumer harm if they aren't aware of it. And we'll talk a little bit more about its destruction later, or lack thereof. But it's really about the cleanability, because the cleanability of the surface, as John has just explained for bacteria, keys in for allergen removal as well. the protein components. But there are various factors that may affect that cleanability and that removal from the surface. So the form of the allergen. So by that, if you take a dairy-based or milk-based allergen, so we can have different forms. If it's a solid, so it's a lump of butter, on a surface, it'll pretty much sit there and not really do a great deal. If it's liquid milk, it will flow from the surface and spread. And if it's milk powder, it will just puff into the air and travel quite some distances. So when you're looking at the cleanability and the cleaning regime concerning allergens, it's crucial that you think about the form of that allergen. The porosity and the texture of the surface. John had some great graphics there showing the bacterial side of things. It's the same for an allergen. If it's for general debris removal from a surface, if it's rough, then it will be more difficult to clean. The cleaning method that you can use, and we'll look at those in a few moments, and also the materials of construction. And there is a sliding scale of surfaces which are more cleanable than others. So stainless steel, if we all had everything made of stainless steel, cleaning would be a lot easier. It's a smooth surface. It's much easier to remove, much easier to use pretty much whatever chemical detergent that you wish to use. If we come down through aluminium, a little bit more difficult, can be smooth, but tends to have a bit more of a surface imperfection. But you are restricted into the types of chemicals that you can safely use without degrading the surface and then giving yourself a cleaning problem. If we come down to hard plastics, again, can be smooth but easy to score, easy to get crevices, or at least look as though they're smooth. But when you actually look at them under an electron microscope, you'll see they're more of the valley type structure. Then we come to soft plastic and rubber that can be difficult to clean as well and easily split. And right at the bottom, most difficult, cloth and wood. And we often see equipment made of from those types of materials, particularly in some of the baking industry, where they may use a cloth conveyor belt or cloth topped conveyor belt, for example, which can then be quite difficult to remove and to clean. In terms of cleaning methods, we've got a range of cleaning methods available to us. And an allergen cleaning doesn't have to be special, doesn't have to be magic. It just needs to be attention to detail and diligently carried out. So the standard cleaning methods you're using are no doubt good enough, but they just need to be considered with an allergen hat on. So manual methods, bucket and brush, green pads, disposable wipes can be used. We can foam or we can gel a detergent onto a surface. And then we have the automated cleans, such as the CIPs, the tray wash, rack washers and robotics. So all of these cleans need to be considered in terms of removal of allergens from a surface. Although there may be different methods, there are common themes here. So key factors: diligence, attention to detail. It always comes down to diligence and attention to detail. We need to make sure that we are putting the time and the effort into doing the clean and doing the clean well. Using the correct cleaning equipment. So if we're using bucket and brushes, we need to be using brushes which don't harbour debris and are easily cleaned themselves. Otherwise, we can actually spread contamination from point to point. We need to use the right type, concentration and temperature of detergent in order to clean effectively. We need to have, as I mentioned, the right time. So we need to have time to actually be able to do the clean properly. The hygienic design group is brilliant with the design of equipment. So equipment needs to be designed so that it's easily to clean. And I'm sure most people on the call can probably close their eyes and picture a piece of equipment which isn't necessarily as easy to clean as maybe we'd like it to be. And then I've also mentioned again explicitly, clean the cleaning equipment. Make sure that any brushes, any squeegees, any cloths are properly cleaned after they've been used to clean, particularly after an allergen. I've had people who've said, well, we only use purple for cleaning for allergens. Yeah, but which allergen? So we need to look at the cross contact between allergens as well as the allergen itself. And crucially, we need to look at validation, verification, and monitoring of the clean. So we need to make sure we know it will achieve the clean. We need to make sure it is achieving the clean every time. And then we need to know that it's actually been done. So those three phases are critical to make sure the clean actually happens. Specifically with CIP, when it comes to allergens, we need to think about it. It's used extensively in our industry, and the concern would be carryover from one product mix to another. And this is probably the key question we get asked with regard to CIP sets and allergen control. And if you properly validate and properly operate the system, that will reduce that risk. And if you've got those stages of pre-rinse, detergent clean, rinse, and then disinfectant stage, hopefully your level of debris and carryover will be greatly mitigated, saving you the problem. If you think about an allergen containing component within the CIP set, you'd hope the majority of it will be removed by the pre-rinse. You don't want, particularly if you've got a recovery system, the debris, a lot of debris going into your detergent tank. It will be consumed and consume your detergent. So, you know, having a pre-rinse, having a good detergent clean, having a good rinse, and then having the disinfection stage, you've got those flows of liquid through, as was shown earlier, and they will hopefully remove the debris and reduce that risk. In terms of detergents, we've got three flavors, if you like. So we have neutral, which are great for emulsification of fats and oils, and as allergens are proteins, that's the rule of the club. Apart from sulfur dioxide, there's always an outlier, but they're all proteins, so they are hydrophobic, so they hate water, so they will bind themselves up in the fat and the oil matrix. So if you're using a neutral detergent, particularly on a manual clean, bucket and brush, which is safer for the operatives, then you're actually using the fats and oils and the matrix that contains that protein to lift them from the surface. So effectively using the fats and oils as a handle to lift the proteins away. When we get into the alkaline detergents with saponification of fats and oils, that's great. So it can be applied manually, foam, or as a solution, as a recirculation. Again, we're looking to start breaking down that food matrix so that we're then taking the debris through. And with acid, not fantastic for cleaning, but great for removing mineral scale and for protein removal, but not brilliant as a general detergency. So if you can get to the proteins, then you can get rid of them. But generally, we use it for mineral scale and milkstone removal. Excuse me. So common problems are how to avoid them. Well, trap points, joints, conveyors, hard to reach areas. When you have a look at a piece of equipment, if you look at it and think, how the heck am I going to get to that bit? That's a trap point. That's the hard to reach point. That's your area where you want to be looking at your allergen testing and your allergen validation and verification to make sure that you've actually got rid of the debris from the hard to reach areas. And joints, conveyors are definitely areas where you need to look, particularly the undersides of conveyors where you may have sort of return rollers and support rollers. Common problems: not enough time, insufficient training, lack of attention to detail, and the use of wrong equipment or chemicals. All things that we can easily control, but do sometimes drift out of problems. And similarly to John, issues where I've been involved in factories looking at what's caused the problem. It usually comes down to something of design or something that physically happened or didn't happen. You know, somebody didn't know how to do things correctly, how to strip something down properly. It was rushed. You know, there wasn't enough time, there wasn't enough attention to detail. So encourage that attention to detail. This is a top tip for effective allergen cleaning. Provide adequate dedicated equipment and the right access to the chemicals and to the right chemicals. Make sure that hygiene equipment itself is cleaned following use, and check, inspect and test. So check the area, have a look. If you can see debris there, needs re-cleaning, inspect it. Verification testing, we'll look at that in a moment. So yeah, there's some top tips for how to achieve an effective allergen clean. Testing then, very, very quickly. We could spend a whole hour talking just about testing. We can use lab analysis, so ELISA testing, which is a lab-based test to validate the cleaning process, and then we can use on-site verification testing. Regrettably, we are all now far more familiar with the term lateral flow and antibody testing, given the scenarios we currently live through, where lateral flow tests are being used more and more. But we've used them for many years for allergen testing, and also a development from that, a flow-through test, which reduces the risk of false positives and bounce back. And they do look very similar to home pregnancy type test kits, where you're looking for lines on the surface to indicate whether you've got a not detected or a detection. One word about DNA analysis. There's a lot of talk about PCR and DNA analysis, again, particularly at the moment. Not really suitable for allergen testing, as we're not then looking for the right reactive material. And it can be quite difficult, particularly if you're doing an allergen product that contains either eggs or chicken. A DNA test won't be able to tell between the chicken and the egg. So DNA analysis is not widely used as allergen testing. What is sometimes described as well, we validate our cleans and we verify our cleans using ATP. The last speaker mentioned that about bacterial, and it's great as a bacterial non-specific hygiene monitoring system. So it is widely used in our industry. However, in allergen management, it's of little use as allergenic proteins aren't actually alive. So low ATP does not necessarily equate to a low protein levels, only low levels of living or recently deceased cells. Yes, if you get a high ATP level, you have probably still got allergenic proteins kicking about because you've got debris there. If you get a low ATP level, however, and I've actually seen this practically in laboratories and in surfaces where we had a low level of ATP, but a high level of egg protein dried to a surface. So you just need to be quite careful using ATP as an allergen detection. With regard to disinfectants and disinfecting, there is a role that disinfectants play in allergen management. In a word, it's none. As I've just said, allergens are protein strands. They are not alive, so you cannot be killed. If I had £1 for every time that somebody had phoned me over the years to say, I need a chemical to kill an allergen, I would be a very rich man. We cannot kill allergens in the same way that we cannot kill viruses. We can inactivate them, we can remove them, but we cannot kill them. It is true that the flow of liquid during the disinfection stage may help to displace any proteins that are on a food contact surface. So if you think about the interior of a pipe or the interior of a mixing vessel, that extra flow of liquid from the disinfection stage and those shear forces may help to displace and remove some, but we're not going to inactivate them or kill them by the action of disinfection. So in conclusion, allergen cross-contamination is all about the clean. And if you aim to minimize allergen cross-contact, then it's about the clean in totality. And I mentioned earlier, there is a white paper that will be circulated to participants later that we've co-authored with the anaphylaxis campaign in order to help explain some of the more intricacies with regard to allergen management and cleaning. And just to bear in mind, 2 take-home messages. Allergens are not alive, so they cannot be killed by disinfectants, and allergens are unaffected by temperature. In fact, some allergens actually increase in their potency when heated. So, for example, if you dry roast a peanut, you actually increase its allergenicity, its potential to cause harm. And as well as the white paper, I'd very much encourage you to go over to the anaphylaxis campaign website. Great charity, great organization, terrible name. It's difficult to remember, but anaphylaxis, but they are the UK's leading and one of the world's leading charities in terms of supporting people at risk of severe allergies. And they do have a corporate membership scheme that is absolutely fantastic for information and for new sort of news on allergens, and is quite cheap depending on your turnover, but annual subscription is very, very low. If it sounds like I'm heavily promoting the anaphylaxis campaign, I am. They're great people and they do a great job. So thank you very much for your time and attention, and if there's any questions, I'll be happy to take those.
Peter, you've got some questions in Q&A. If you can see Q&A,
I'll stop sharing my screen, because when I share my screen, the Q&A disappears. So I'll stop sharing that for a second. There we go. Right, let's have a look. Let's have a look. Let's just scroll down. There's a couple there for John. Is there a difference in the ease of cleaning between allergens, particularly heated products? Yes, if a product is been baked and is very set to a surface, it's going to be very difficult to clean whatever you do, irrespective of whether you're looking at an allergen or a standard clean. So yeah, the more a debris is baked on and set onto a surface, the more difficult it's going to be to remove. So yes, if it's been heated, it may be more difficult. How good is ATP testing? Phenomenal testing. Great system for non-specific hygiene monitoring. Been around for many years, has gone through lots of iterations. As I say, very good for non-specific hygiene monitoring. Quick test, job done, perfect. However, if you're looking at it specifically with allergens, then as I've said, it doesn't really feature or work that well for allergen detection and testing, because, as I said, a high level of ATP will give you a high level of debris, but a low level of ATP just means a low level of debris, and some of that may be proteins, some not be. So it's not specific for proteins. So you need to be using specific verification tests, such as the lateral flows or the flow through. Question regarding mention targeting the fatty food matrix still for protein allergen, but protein also adheres to mineral deposits. It does indeed with WHO temperatures. Clarifying which components does the majority of protein lie in? Charlene, I wish there was a simple answer to that. It depends very much on the protein. Oh, sorry, the debris. It depends on the allergen component, depends on the process it's gone through. This is why when we look at validating and then verifying the cleans, we have to validate the entirety of the clean. You cannot validate just a single component. So, for example, the process, you've got to do the whole process. You can't just validate, for example, the chemical. You've got to validate its use against that particular scenario. So it depends very much on the composition of the product. But maybe we could take a more detailed conversation offline, just in the interest of time, because I'm conscious I don't wish to steal any of Lucy's time in a few moments. And the final question there, can allergen levels accumulate in recoverable CIP detergent tanks to dangerous levels? How would you recommend control of this? I've not known it, providing that the rinse process and you haven't got reservoirs and dead legs where you've got debris coming through. Providing you've got a good, well-functioning CIP set, then you shouldn't have debris building up in your recoverable detergent tank. It's something you want to avoid, and you do. That's the reason you do the pre-rinse. You'd hope that the majority of your loose debris will be taken away for that, and the detergent will be just removing what was sealed to the surface. So it's a case of monitoring it. You recommend, in terms of control of that, pre-rinse, making sure the pre-rinse is effective, making sure it's done correctly. And if you are looking at testing your recoverable detergent or indeed rinse tanks to see if there's any buildup of allergenic debris there, then swabbing things like any filters will help you, because they can act as accumulation points for trapping debris, which will also be trapping any allergenic proteins that are there. I think that's all the questions that have come through for me. Yeah. Okay, if there's any other questions, happy to try and answer them.
Can I also make a comment on that last one, Peter?
Yeah, sure.
Allergens tend to be removed with the first product down the line on open systems, but in closed systems, if you have allergens in dead legs, they tend to be released throughout the production process and through the cleaning process. So it is possible to get carryover of allergens into the recovery tank, particularly from dead legs. Those are the most problematic. So as long as you don't have any dead legs, and as Peter says, the cleaning system and the rinses are fine, it shouldn't be a problem. But dead legs can create issues sometimes. Thanks.
Yeah. They do all, yeah, they create issues across the whole board, really, don't they, John? It's
Yeah.
it's when the engineers decide, well, we'll stick a T-piece in there just in case. Okay, if there's no final questions, I'll drop back on mute and hand over to Lucy.
Great, thank you very much, Peter. Let me just start my video and share my screen. 1 second. I'm hoping everyone can see that. If anyone can confirm, that would be great. Can you all see my screen?
We can see you.
Fantastic. Great. Well, thank you very much, John and Peter, for your presentation so far. And thank you, BFBi, for having us today. It's a pleasure to be here with you. So my name is Lucy, and I am the Partnership Client Executive here at Safety Culture. And what that means is that I work with partner members like yourselves if you sign up to iAuditor to help you get started, use it and apply it to your specific needs. So I'm going to start today's presentation by giving you a bit of insight for anyone who doesn't know iAuditor yet, giving you a bit of insight into what it is and what it does. I will then hand over to my colleague Maria, who is going to talk about how our customer Muller has used and implemented iAuditor. And we will finish off with my colleague Mike, who will explain how Yeo Valley has used our sensors. But first of all, what is iAuditor? So at its core, iAuditor is a digital platform that allows you to raise your operational standards and reduce your risks. Now, there's 5 key areas within this single platform of how this is achieved. So initially, iAuditor is an app that you can have on your phone, and it also has a web platform as well. And within that, you can have these 5 key sections. So first of all, you can complete inspections. So for a lot of the things that have already been discussed today, and a lot of the things that I'm sure you all do day to day, you have to do a lot of checks and inspections and managing everything. With iAuditor, you can do that all from the app. So you can take those paper checks and do them online. You can also we also offer sensors within iAuditor. So this allows you to monitor and capture data consistently, and you receive alerts when things go out of range for things such as temperature and humidity, which again, my colleague Mike will delve into in a bit more detail. But you can also create actions in iAuditor. So these can be things that need to be completed. They can be assigned to a specific person. You can set due dates and set priorities for this. So everybody knows exactly what needs to be done and when it needs to be done by. You can create issues and observations. So hazards, accidents, near misses, anything that you need to capture detail on, you can do through iAuditor and act on this accordingly. And finally, we offer training through our sister company, EdApp, which is a micro-learning platform to make training more engaging and dynamic. Now, all of these 5 areas are underpinned by the 3 things at the bottom. So if you complete the inspections online and digitalize that, you also get access to instant reports. So they're there, the minute you press complete, you have a report ready and you can personalize how that looks and how that's formatted as well. You get access to analytics. So everything that you input into iAuditor feeds into analytics, where you can really deep dive into your data, pick out trends, see what's working, what's not, and analyze that appropriately. And you can also manage your team. So you can control who sees and who has access to do what within this. So you'll see on this slide a little bit of a demonstration of iAuditor in action, and hopefully start to picture how all these 5 things work together to help you control and capture what is happening on the ground and use that to raise your operational standards. So from this slide, you can see that we are used and trusted by a vast number of brands already. It says over 25,000 customers. I think that's up to about 27,000 customers now worldwide that we've got. And all these customers use iAuditor for a wide range of things. So you can use it for things such as quality control checks, maybe even cleaning checks like Peter's ran through, COVID checks, health and safety management, cold store management, and many more. Just to give you a bit of an idea, last year alone, over 600 million checks were completed. However, despite the vast number of industries and customers that we work with and the wide use cases that we've got, we have a lot of knowledge of your industry specifically, which is why we have partnered and worked with the BFBi over the past few months, which we're really pleased to be a part of. And we've worked together with the BFBi to create some industry-specific inspection templates, which you can all sign up to and access for free by just following that link at the top there. But if you've got any questions about that specifically, please do reach out to me and I'd be more than happy to help. And for now, I'm going to hand over to Maria, who will delve into the specific use case of Muller in a bit more detail.
Thanks, Lucy. Working with several customers within the brewing, food and beverage industry, we've seen hundreds of use cases for iAuditor. But without a doubt, one of the risks receiving the most focus through our platform is ensuring employee safety. So by highlighting non-conformities and assigning corrective actions, you're not only mitigating risk and potential costs for your business, but you have documentation that you did not only uncover a non-conformity, but you corrected it. The benefit of doing regular checks, inspections, and audits is that you take a preventative approach to your safety. You ensure that the working conditions for your employees are up to the standards they need to be to minimize risk and ensure that your colleagues can return home to their families. Muller UK have been using our auditors since 2018, and the interest in the tool has grown steadily since. Their main pain points were wanting to digitizing their processes, were initially a desire to reduce the amount of papers they use, aligned with the climate change agreement, and also wanted increased visibility and accountability across their sites. So alongside a rollout in Germany in their headquarters, several sites in Muller in the UK discovered iAuditor on their own initiative and implemented the system at their sites. So since that, we have merged all of Muller UK into one account in our system, allowing them to share relevant templates across functions and sites, and they've seen some absolutely amazing results. By reducing the time it takes not only to complete a check, but the duplicate work of inputting the data and then trying to get some analytics from it, they've seen a return of 4 times ROI in time saved for employees. So with digital checklists, you have the ability to customize items quickly at a moment's notice, meaning that your audits can be tailored to meet the exact requirement of that inspection, and it's all updated real time. It will encourage faster and more accurate reporting, and you're gathering data to reduce risks, flag issues before they escalate, and identify trends or areas for improvements to drive efficiency. So Jan Stitch, a supply manager from headquarters within Muller in Germany, has quoted, "Everyone working together can only be a good thing," and it's definitely gathering momentum across the business. So just to expand on that quote from Jan a bit as well, he continued to say, "You can use iAuditor for absolutely everything. We have hundreds of ideas about where to take it next, machine checks, maintenance plans, and more. And I honestly believe one solution that covers everything is far better than having each department working independently." So now, having established iAuditor as the go-to tool for any checks for Muller, I spoke to my main contacts with Muller UK, Clive and Elizabeth, about how we can further extend the support to them in 2021. And a key thing for them that I'm sure you can relate to is to find a more efficient way to monitor temperature at their depots. So at their milk depots around the UK today, they have to monitor the temperature in the fridges where the milk is stored before it's shipped off to customers. And this is done in various different ways at the moment across the depots, ranging from readings, manual readings, to these old sensors noting temperatures on discs by drawing a line on a piece of paper. So they kind of want to evolve from this, and this is the next step for us in helping Muller improve their business. So I'll hand over to Mike now to take you through what our sensors look like and another use case as well.
Thank you, Maria. Excellent. So as Lucia said earlier, I'm Mike and I'm an onboarding manager here at Safety Culture, and I'm going to touch on our sensors offering. So first, an overview of what we offer. So we have IoT 3G sensors that provide real-time visibility of environmental conditions without any work, really. So instead of relying on a team to regularly check your assets and that your people are safe, and then manually recording that information, The sensors, the digital sensors, allow you to automate this process, and then all of the data is logged within iAuditor. So you can set automatic alerts when these environmental conditions go outside of critical ranges so that you can respond on the spot. Now, the way it works is we provide wireless battery-powered sensors to be installed in the area that you want to monitor. These sensors then send the data back to a 3G powered gateway that connects to the Safety Culture Cloud, which means that we can then present this data to you in a meaningful way in your iAuditor account. So let's move on and take a look at a company that use our sensors. So I'm sure you're all aware of the company Yeo Valley. Here is a lovely drone shot of one of their locations, and you'll see down towards the bottom right of the picture, we've got rows and rows of solar panels. This location is actually ran off 100% green and renewable energy, which is obviously quite a modern way for a business to operate. So you'll be sure to understand the shocked look on our faces when we were presented with the temperature monitoring system that they had in place. So this is what they were using. This is a spirograph system, and it's got several pens connected to it, and it will record the temperature at certain points throughout the day. And we found it quite bizarre to see this wonderful modern location running on renewable energy, recording their temperature on this sort of Wallace and Gromit-esque machine. And the main pain points for them with this system were that it was a lot of manual work. So the paper within there needed to be changed every 24 hours. And if the pens were to run out of ink, no data would be recorded until they were replaced or refilled. And then on top of that, the alert system wasn't ideal. So you can just about make out that there is a red light just above the picture, and that would flash every time the temperature went outside of a certain range, and it would also sound an alarm, which sounds good until you realize that only the people inside of the fridge at that time would be privy to this alert. So this wouldn't actually notify anybody else unless you were in the fridge. And then furthermore, the data that they were collecting wasn't digitized, meaning that management of this data and then locating any historical data really wasn't the easiest of tasks. So this is where we stepped in. So after the initial installation of several sensors and a gateway and the really easy, quick initial setup, there was really no more work to be done. All of their readings were automatic and digital. So we set up an alert system for each sensor, meaning that anyone, anywhere, could be alerted when the temperature went outside of the critical range that we agreed upon. And then all of this information was available in their iAuditor account, like I say, displayed in a meaningful way, in real time, with all historical data easily accessible. And another huge benefit of digital sensors is the impact that it can have on carbon emissions. So if we're able to be alerted in real time when a temperature spikes, or even if you're using a different sensor to note when a fridge door is accidentally left open for too long, you can drastically reduce waste as well as our carbon footprint. So that's it for us. If anybody's got any questions, as per the previous presentations, please just pop them in the Q&A now and we'll endeavour to answer them. I think there's just a couple of resources on these next two slides.
Yeah, so just again, that's the link if you do want to sign up and have a look at some of the templates we've created, follow that link. If you've got any questions or want any more information, if you just scan that QR code, it'll take you to my email. So I'd be happy to answer anything or follow up in any way after this. I can't see if any questions have come through.
Yeah, I've just seen a question